wonderful knowledge to share with us. I request all the students to make use of these sessions and note down the important points and improve your knowledge and interest in research and the field of mathematics. Thank you so much. I thank Principal Sir for giving me this opportunity. Thank you, sir. I request Dr. K. Ramesh Babu sir to take over. Thank you, sir.
Thank you so much.
టేబుల్ అయితే మంచిగా వస్తుంది. అది స్టూల్ 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 ఏం లేదు ఉండాలి.
సౌండ్ కూడా ఎక్కువ వస్తుంది.
సరే సార్.
ఏది మేడం? కవర్ చేయాలి. ఆగనా సార్?
సార్ కవర్ చేయాలి. సార్ కవర్ చేయాలి.
సార్ ఇక్కడ వస్తాం. ఇక్కడ వస్తాడు కదా సార్.
Good afternoon to all. So today I am going to explain about the role of mathematical modeling and its innovations. This is completely one national workshop. Sir, next. So this is all not required. So just showing, sir, showing this. So last time I have given one lecture, National Mathematics Day in Twin Cities one college. So that's why I am showing like these pictures. But for you it is not required in this case. Next. Now outline of this presentation. Contents, what is that here? Motivation, history of equations, why we learn equations, very useful equations, motivation to differential equations, what is differential equations, fundamentals of differential equations, physical examples of differential equations. So this is all we have studied in differential equations. Mathematical modeling is nothing but what is that differential equation. In all such cases also in mathematics, very important role in engineering field, science, medicine, finance, technology and statistics and etc. So without mathematics, we could not get any values, any solutions. In all these cases also you must and should apply mathematics subject. So history of equations. Now next motivation. Motivation. Finding. See what I told you just now. I have seen here. Mathematical sciences work is becoming an increasingly integral and essential component of doing array of areas of investigation in biology, medicine, social sciences, business, advanced design, climate, finance, advanced materials, and much more. This talk involves the integration of mathematics, statistics, and computation in the broadest sense and the interplay of these areas with areas of potential application. The mathematical sciences are best conceived as including of all these components. So all these applications of mathematics we can apply in medicine, biology, and like this. Then we will get some solutions as per this motivation. So next. History of equations. History of equations. Now see, mathematical sciences. How many mathematics we can apply in all these cases? Just learn all of you. Mathematical, material sciences, engineering, biological science, physical sciences, medical sciences, social sciences, economics, finance, math, education, government, communications, manufacturing, engineering, geosciences, material sciences. In all these cases also we can use maths. Is it correct or not? Definitely, we can take mathematics. Mathematics means what is that we can calculate. You take any concept, you can calculate, and if you have any formula, you can use formula and get it the solution. In all these cases, also different formulas are there. So already we have studied in long back in some Pythagoras theorem and in Newton laws and Kepler laws, whatever. So in these all cases also we have some formulas like F is equal to ma, what is the force, what is the mass, what is the acceleration, like that. Next. Next. Now introducing new courses proposed. What are the new courses proposed in mathematics for space system, sports science, bioinformatics, quantum computing, robotics, stock market, anthropology, mathematical techniques in multi-sensor data fusion, mathematical models of solar energy, mathematical theory for mathematics for Borel sensor. See, in all these cases also, we can take maths in sports science. In sports science means already you are playing volleyball, football, ring ball, like that, everything. So in sports science means just you can calculate what is the length, what is the width, what is the height. You can take you can apply maths here also. Without maths, we can take length value here. And robotics, this is the latest concept nowadays. In robotics also, we can use maths. And stock market, more market, demart, like that, we have so many markets are there. If you want to build, if you purchase anything, then you can calculate maths equations and like that. You can take stock market. And solar energy, anthropology, automatic vehicles. That real world lives also we can use in maths, in mathematical modeling is describe mathematics and language throughout in a real world life. Next, history of equations. Differential equations. These are two dynamic authors, Isaac Newton and G. William Leibniz. Next, introduction to equations. These are also some authors. Why we learn equations? How to learn our mathematics equations here? Heart of the analysis of the physical systems. One of the root cause of the development of science and engineering. Differential equations are used to express many general laws of nature and have many applications in physical, biological, social, economical, and other dynamical systems and etc. So here we are taking such as applications in physical, biological, social, economical, and other dynamical systems also we can learn and we can apply math. Otherwise, we should not get the values. And definitely, must and should we can use mathematics formulas. These are our applications. Creating softwares, constant logic programming, creating games, aspects of algorithms, mother nature, bots, artificial intelligence, networking, in theories and explanations. These are all some standard languages you can use in especially in research field. So many softwares I told you at the beginning, Mathematica, Mappil, Python, MATLAB. But nowadays the students are using generally MATLAB. Everyone is using MATLAB only. Use the system and take the program and get the what is that graphs and immediately you will get the results. But not like that in Mathematica, Mappil and Python program. First, you have studied and how to take these programs in all these cases. These are very, very important and difficult also. Sometimes we could not get real values. So, not like that MATLAB. Many softwares are there. Nowadays, artificial intelligence came. Next. Where these useful differential equations? The differential equations are useful for all engineering branches like CSE department, EC department, EEE department, mechanical, mining, aerospace engineering, civil engineering, biotechnology. But nowadays students are taking BA, BCom, MSc mathematics. They are all taking maths and simply they are studying only without concept anything. But if you take all these engineering branches also, you will get more knowledge compared to our MSc Maths and BCom BSc. You can calculate and use also mathematics in all these fields. Next. Motivation to differential equations. How many different types of equations? See, take one example, 5x plus 7 is equal to 0. This is one linear equation. In this one linear equation, there is only one variable. What is that? X. 2x plus 3y is equal to 5. This is also another linear equation. How many variables are there? X and y. Sin x minus cos x is equal to 0. This is called as the trigonometric equations. Log 4x to the base 2 is equal to 3. This is called as the logarithmic function or logarithmic equation. E power x minus 2 is equal to 1. This is called exponential function. See, whatever you take, you can apply math immediately. Even there is a logarithmic function. Log 4x to the base 2 is equal to 3. There is only one variable x. How to calculate this one? As per logarithm procedure, you can omit logarithm and get it xy. So, and so many different types of equations are there. So these are all some different types of equations. What is differential equation? A mathematical equation that relates a function with its derivatives is called differential equations. The functions usually represent differential physical quantities and rate of changes. Differential equation defines the relationship between functions and derivatives. So, dy by dx plus 4y is equal to 5. One is called a differential equation or 4x. Here y is a coefficient to what is that? D by dx. So y is equal to function of x. And giving y is equal to function of x, now take differentiation with respect to x, you will get dy by dx. But there is a x independent variable and y dependent variable. Now you can use the physical quantities also and rate of changes also. Rates of changes means slope. So how to get slope in a trigonometric level, in mathematics level, in coordinate geometry level also you can get slopes. So you have seen already in intermediate level. Next. See, just now I told slope and rate of change. Slope formula means what is that? Change in y by change in x. Change in y by change in x, I have shown one graph. I have taken one example. We can find an average slope between 2 points in x and y. X axis and y axis. See, compared to with the graph, what is the change of y? 24. What is the change of x? 15. As per this formula, what is the average slope? 24 by 50. Without formula, you can tell the answer. Now, how can find the slope at a point? There is nothing to measure but derivatives. We use a small difference, and in this case also I have given slope delta y by delta x. Next. So sometimes 0 by 0 is coming. It is not the exact value. It is called as indeterminate form. We cannot get the answer. Next. Definition of differential equations. An equation which involves derivatives or differential coefficients is called differential equation. Just now I told. Y is the function of x. What is coefficient? D by dx. This is called as a differential equation. And an equation which involves derivatives of a dependent variable with respect to one or more independent variables is called as a differential equation. See, if you take a dy by dx, so one is independent variable y and x is independent and y is dependent. Rate of change of y with respect to x is called dy by dx, can be represented as the derivative. Similarly, you can calculate dx by dy also. Next. See, these are all some examples of differential equations. Dy by dx plus 6y is equal to 0. Here, dependent variable, what is that? Girls, boys, degree students, y. And what is independent variable? X. But what I have given function? Y is equal to f of x. D square y by dt square plus 2 dy by dt plus 4y is equal to 0. What is dependent variable? Y. What is independent variable? T. Dou square u by dou x square plus dou square u by dou y square plus dou square u by dou z square is equal to 0. So this is called what is that? Partial differential equation. Actually, there are two types of differential equation. One is ordinary differential equation, and another one is partial differential equation. In this case, what is dependent variable? U. Independent variables are x, y, z. But how to choose the function? How to choose function? U is equal to some function of x, y, z. U is equal to some function of x, y, z. You can calculate first time, second time, third time, whatever if you want, you can take. X dou u by dou x plus y dou u by dou y is equal to nu. Here also u dependent variable and x and y independent variable. Don't say n, but n is degree. This is also known as a Euler's formula. Next. Types of differential equations, just now I told ordinary differential equation and partial differential equations. Next. How you can define ordinary differential equation? An equation which involves derivatives of a dependent variable with respect to single independent variable is called an ordinary differential equation. You have to take one single independent variable. You can take number of differential equations. Then we can calculate whatever asking. You can take. I think already you know some differential equations. I am telling here. Dy by dx whole square minus dy by dx whole cube plus 7y is equal to cos x. This is one differential equation. Here, independent variable y, dependent variable is x. Next, how to calculate differential equations in real life? Real world problem, you can take a mathematical model, mathematical solution. So, what is this concept? Mathematical modeling, what I told, always you will get solutions in real world life. Whatever you take in mathematical model in abstract, whatever formulas and applying, then you will get a solution. That should be called as mathematical solution. So I have shown the arrow mark clearly. That is the meaning of if you take mathematical modeling problems, then you can use maths, whatever applications are there, then immediately you will get a solution. That should be called as mathematical solution. Next. Take some examples. Dy by dx plus pxy is equal to qx. Here dependent variable x and independent variable x. In differential equations, you can solve many methods are there in variable and separable, homogeneous differential equations, non-homogeneous differential equations, exact differential equations, linear differential equations, Bernoulli differential equations. So these are all in differential equations with order 1 and degree 1. See, dy by dx plus py is equal to q, where p and q are in functions of x. So it is called as what is that? Linear differential equation. Then whatever procedure is there, you can take I think integrating factor and what is solution, y into integrating factor is equal to total integration of something, then get arbitrary constant. Same like this also, variable separable. For example, dy by root 1 plus x square dx by root 1 plus y square is equal to 0. How to calculate this expression? dy by root 1 plus x square dx by root 1 plus y square is equal to 0. Just I am asking mathematical modeling I have given. Then you will get mathematical solution. How to solve? You have so many methods. You can apply. I think I am taking a variable and subproblem. Just you can take by cross multiplication, you will get everything. Sometimes you can rewrite also. You can take character cross multiplication, root 1 plus y square dy plus root 1 plus x square dx is equal to 0 and apply both sides integration. Whatever formulas are there, we can apply. So now homogeneous differential equations also, you know, there is formulas f of kx ky is equal to k to the power of n f of x comma y. So take one dy by dx any function. You can use this concept. If it is satisfied, then the given differential equation is said to be homogeneous differential equation with the order n. Take any values. For example, simply I am taking x square plus y square is equal to x plus y. So this is called as f of xy. F of xy is equal to x square plus y square by x plus y. Then you can find and replace x by kx and y by ky. Then you will get left hand side f of kx and ky. At the same time, you can substitute also right hand side. K square x square plus k square y square by kx plus ky, and take k square common factor from the numerator and k common factor from the denominator. You should get k power 1 and remaining part should be called as f of xy. So comparing this result, you got order n is equal to 1 and it is also satisfied. I am giving the mathematical modeling, this is abstract, then I called this is mathematical solution. This is called as a homogeneous function with order 1. Non-homogeneous also, you know that exact what is that mdx plus ndy is equal to 0. Where is the m is also mf of xy, n is also f of xy. Intermediate students already now we are studying in 1b. These are all methods. Remember all of you? In 1b. Now you can continue degree level, it is not coming. From exact differential equation onwards, it is coming. Next, second take example, d cube x by dt cube plus 5 d square x by dt square dx by dt plus x is equal to 0. This is the one x dependent variable and t is independent variable. What is the general form of ordinary differential equation? F of x comma y comma dy by dx d square y by dx square d power ly by dx power n is equal to 0. This is a general differential equation form. Next. Second part, the partial differential equation. An equation which involves derivatives of a dependent variable with respect to two or more independent variables is called partial differential equation. Otherwise, a differential equation which involves more than one independent variables is called partial differential equation. Just now I told you x dou u by dou x plus y dou u by dou y is equal to n times u. Don't take n times z. If you want to take z, you can write down dou z by dou x plus y dou z by dou y is equal to n times z. But how to take a function here? U is equal to function of x comma y. U is equal to function of x comma y. One independent variable, two dependent variables, so more than two independent variables also you can take. Next. See like this example, so dou square u by dou x square 1 by c square dou square u by dou t square. Here u is the dependent variable. How many independent variables are there? Two. What are there? X and t, but don't say c. But c is constant. And dou square u by dou x square. See similarly second example also. U dependent and independent. There are three: x, y, z, and you can take function u is equal to f of x comma y comma z. Next, how you define the order of a differential equation? The order of a differential equation is the order of the highest derivative appearing in the differential equations. dy by dx plus py is equal to q. Order is 1. Second example, you see dqy by dxq whole square 3 dy by dx whole square minus e power x is equal to 4. But what is order? 3. What is the highest derivative? You focus on that. Here, highest derivative in the above equation dqy by dxq. That is called order. D square y by dx square plus dy by dx plus 6y is equal to sin 5x plus cos 2x. So in this equation, what is the highest derivative? Second order. D square y by dx square, that order is 2. Next. What is degree? The degree of a differential equation is the power of the highest order derivative after the differential equation has been made free from radicals and fractions. See, all these examples I have taken. Simply you can find as per definition of degree, what is the degree you can take. dy by dt whole square plus xt is equal to e power t. What is degree? 2. But what is function here? Y is equal to function of t. You can take a differentiation with respect to t. In second example, highest derivative is d power 5y by dx to the power of 5. As per definition, which is the highest derivative? This one. But power is called as degree. What is degree? 3. D square y by dou square t square dy by dt minus 7y is equal to 5. Highest derivative d square y by dt square, it should be called as degree. What degree? 1. Next. Real example of a differential equation. So just now I told mathematical modeling. Real example of a differential equation. Write a differential equation, describe this scenario. F is equal to m times a. See, F is called as force, m is called as mass, a is known as acceleration. Acceleration. So this force is depends on mass. It is coming by a. So this is known as F is equal to m of a. So as per arrow marker, I have shown everything. But V is called, what is that V? Intermediate level, degree level. V is called as, right, velocity, and dx by dt, it depends on time. A is called as acceleration, dv by dt, it is velocity with respect to time. And f of is equal to ma, f is equal to m, what is a, dv by dt, and also you can substitute v also here. What is v? Dx by dt. Then you will get second order differential equation. And take cross multiplication, how to rewrite d square x by dt square minus f by m is equal to 0. This is one differential equation. But order is 2. What degree? 1. Every time you can get order at degree. This is one scenario in real world life in mathematical modeling. Next. So these are all some examples in mathematical modeling. Next. These are applications. Already you know very well Newton's law of cooling, Kepler laws. I have seen everything, investigations, computer, manufacturing, solar water heater, calculating the surface area of an object. These are all some applications in Newton's law of cooling. Next. Physical interpretation and geometrical interpretation, both are there. Now, till now we have studied physical, geometrical. Now, what is the physical interpretation? Spring mass system. Spring mass system. Consider a mass suspended from a spring attached to a rigid support, and it is called as a spring mass system. As per this figure, what is equilibrium position? Minus k into x, but k is called as the spring constant. By Newton's second law, you can apply, you will get mt square x by dt square is equal to minus kx, which is our required differential equation. Then order 2 and degree 1, but k is called what is that? Spring constant, and x is a dependent variable. Next. These are all some rockets. Even last time also ISRO, they did everything. In that ISRO also they have used mathematics. See, intermediate boys, degree students, we can use in rockets also. Definitely we can apply maths. If without maths we should not go to rocket here. See, I have taken like this some films, pictures. So how to use the mathematics, the formulas in this case also, laterally we will study in further procedure. Next. See this physical example of differential equations in rocket science. Even the elementary equation of rocket science, mdv by dt is equal to minus u dm by dt plus f. It is also one differential equation. What are the observations I have given here? M is the mass of the rocket at the time t. V is called velocity at the time of t. F is called external force, and U is called velocity of gases related to rocket. Next. See, this some softwares. Just now I told you Mathematica, Mapping, Python, MATLAB, and etc. We can use math software also. Many things are there. Next. See, just I am showing only. Next. Mother Nature. Next. Bots. This is also one software. You remember and keep in mind, all of you. Bots. Even go back. Even this bots you can use a partial differential equation and ordinary differential equations also. Like this helps to provide shape and interior and exterior designs of machine. Interior also and exterior also you can use this one in bots softwares. Next. Already I have shown one figure. You can imagine what is the figure. And artificial intelligence, nowadays the engineering students, most of the engineering students, they are taking artificial intelligence and data structure, AIT, and artificial intelligence and machine learning. Even this one also we can use maths, definitely. Previously it was not there. Only CSC students, they are taking CSC, computer science. Under CSC also it is coming down. AID, AIDK, and cryptography, cybercrime, lot of things are there. All times you can use mathematics software. Because now I am working in engineering college, my students also AML students. AML, artificial intelligence and machine learning. I am taking classes in this case also. Solutions. Generally, it is more difficult to obtain an analytical solution than a numerical solution of nonlinear differential equations with the help of the symbolic computational software mathematical mapping. I told already. Analytical solutions has been derived for some coupled system of nonlinear differential equations. So there are two types of differential equations. Linear differential equation and non-linear differential equation also you can use this software. don't think mind, other mind, because non-linear differential equations will have lot of applications are there compared to linear. It is also most useful subject for research point of view. Next. So how to related rates as per this title? What is optimization problems, tangent lines, curvature, implicit differentiation? See, optimization problems also we can take maths that is called as operation research. Operation research and discrete mathematics studied only computer science. Not only computer science, you can use MSc maths also, or and this data structure. Even that case also we can use maths like this options. And tangent lines. Tangent lines, many things are there, or are very well known. Curvature. Curvature also, radius of curvature is there, circle of curvature is there, center of curvature is there. In this all curvatures also many points are coming, asteroid, and some difficult words also there. You can take also maths in the curvatures. And implicit differentiation. Implicit differentiation means it is also called as total differentiation and chain rule and Jacobian. All these cases also you can use maths applications. But I have given only implicit differentiation. In that implicit differentiation, so many things are coming. Not only this one. Next. So thank you very much. Because in some students, intermediate degree students are there, but this is our village. Actually, I told already to your Ramu sir, just I have taken lecture on the blackboard on any subject, either degree subject or intermediate subject. I don't have any problem. So if you want to prepare the PPT, like this is showing, see, girls and boys, intermediate and degree students, they are boring. And they are not listening properly because they don't care. Never, I know that they are not understanding. What is this PPT, what is going on, what sir is telling, if a student is asking, another student, no, I don't know anything. She is saying simply. Yes, is that or wrong? I know that same thing also I told to Ram sir. So they are, what they have habit in classroom, only blackboard and dusters and sharpness. It is important. If you prepare like this, why I am preparing this PPT for to your students, you will get some innovations. You will get more concepts. See, you know rocket, you know space system, degree students, intermediate students, you don't know anything. Robotics, do you know? No. Huh? That's why I have taken more pictures also for this PPT. Only because of you, I have taken. See, in all these cases also use differential equations. So many methods are there, but I forgot one more point. All these differential equations also I have applied only first order and first degree. You remember this point. Even you can take a second order degree equations also there. In second order degree equations also linear, non-linear equations also there. Some more methods are there. You can take that applications also, geometrical and physical applications also there. But only I have chosen first order and first degree in ordinary and partial. But take second order also, third order also, you will get some results. I have shown in the real world life means what I told, mathematical abstract taking and mathematical modeling solutions we are getting. It's clear? All of you. Thank you so much. Thank you very much.
Thank you, sir. Thank you for giving wonderful lecture. Actually, sir is busy with NDA testing agency examination duties. Actually, you want to cancel the program yesterday. So I don't. Okay, I will request you don't do like that, sir. Actually, your purpose is very appreciation for coming here. In busy studies also, he prepared brief lecture. I told him to prepare 1.5 hour lecture only. So due to that only, he prepared 1.5 hour lecture only. We will complete within half an hour the program, entire program. So if any have doubt, okay. ఎవరైనా డౌట్ ఉంటే ఏదైనా జనరల్గా మాట్లాడాలనుకుంటే ఓకే. Actually, we also did some project on in this topic only, the Jignan project. Our student will present regarding this.
చేద్దాం చేద్దామా చేద్దాం. ఎక్కడ ఉంది సార్ ఇది? పెట్టేసి చేసిన అది తీసి పెడితే సార్ అంటే ఇవి లైవ్ కూడా మళ్ళీ దానికి వస్తుంది. రీసెంట్గా ఓపెన్ చేసి పెట్టి పీపీటీ ఓపెన్ చేయండి సార్, దానిలో రీసెంట్గా ఓపెన్ చేస్తున్నాను. ఓకే సార్. Yes.
కరెక్ట్ అది అని 25 మధ్య పైన పైన
Good afternoon, all of you. A student study project exploring the application of differential equation in real. A student study of project in the exploring the application of differential equation in real world problem under the supervision of Dr. P. Ramulu sir, Head Department of Mathematics. M. Akshaya, P. Lavanya, P. Venkatesh, C. Venkatesh, G. Deepika. Content, hypothesis, aim and objectivities, abstract, introduction, review of literature, methodology, finding of study, conclusion, reference. Hypothesis, a student study project on exploring the application of differential equation in real world problems. Aim and objectivities. Aim to understand the role of differential equation in modeling and solving real world problems. Objectivities. Exploring application across physics, biology, engineering, economics, and more. Understand mathematical formulation and practical implication. Analyzing a case study showcasing analytical and numerical solution. Over to my friend Venkatesh.
Abstract. Differential equation provide a mathematical framework for dynamic systems. Applications span multiple disciplines such as physics, motion of electrical bodies, biology, population growth, engineering, electrical circuit, economics, market dynamics. Includes a detailed case study highlighting their versatility and practical impact. Introduction. Differential equation describe relationship between function and their derivatives. There are two types: ordinary differential equation, single variable function. Partial derivative equations, multivariable functions. Key application. Predicting growth and on. Key applications: predicting growth and decay, simulating physical and biological process. Focus: breeding theoretical concepts with practical impact. Thank you, man. Over to my friend.
Review of literature. Historical perspective. Newton origins in calculus. Euler solving ODS. Fourier. PDS in heat conduction. Theoretical advances. Existence and uniqueness theorems. Classification of PDS. Applications. Physics, biology, engineering. Methodology. Research and problem identification. Conduct a literature review. Select a case study. Theoretical framework development. Study solution methods. Define initial and boundary conditions. Mathematical modeling. Derive governing equations. Validate with empirical data. Solution and analysis. Use tools like MATLAB or Python. Visualize and interpret results. Case study implementation. Role in modeling. Describes dynamic systems across disciplines. Tailored solution using initial and boundary conditions. Solution methods. Analytical techniques for simpler equations. Numerical methods for complex problems. Applications. Physics, harmonic oscillations. Biology, epidemic spread. Economics, resource allocation. Case study insights. SAR model for disease spread. Parameter sensitivity and real world implications. Physics, motion under gravity, heat conduction, biology, logistic growth model, epidemic modeling, engineering, vibrations in spring mass systems, RLC circuit analysis, economics, market dynamics, solar growth model, environmental science, pollutant dispersion, climate modeling. Case study. Focus. SIR model for disease spread. Components. Suspectable, infected, recovered populations. Governing equations. dt is equals to minus beta Si. di by dt is equals to beta Si minus gamma I. dr by dt is equals to gamma I. Findings. Impact of infection and recovery rates. Threshold for epidemic control. Policy recommendations based on simultaneous. Challenges identified. Complexity of non-linear equations. Dependence on accurate data for parameter estimation. Computational limitations for high dimension systems. Conclusion. Differential equations are vital for modeling and solving real world problems. Analytical and numerical methods complement each other in understanding complex systems. These are the references. Thank you.
Actually, I have attended this Jignasa program 3-4 times. CC officer has been appointed to me as a subject expert. 4-5 times I have attended. But in our village side, actually I am giving importance, especially Mangla district. to anybody, don't tell to discuss with others, just they should keep in mind. కాకపోతే ఏంటంటే మన విదేశ్ సైడ్ వచ్చే స్టూడెంట్స్ అది భయపడతారు ఎక్కువ. భయపడాల్సిన అవసరమే లేదు. ఇప్పుడు చూసి చదవడానికి కూడా ఆ అమ్మాయి భయపడుతుంది. సిమ్యులేషన్ అనేది పోయి వేరే వర్డ్ పడుతుంది. అండ్ డిఫరెన్షియల్ ఈక్వేషన్ అనేది పోయి డాట్ ఏమంటుంది. అలాంటివి కూడా some మిస్టేక్స్ ఉంటాయి అక్కడ. మీరు పాయింట్స్ వేసినప్పుడు మీ వే ఆఫ్ టీచింగ్ అనేది, వే ఆఫ్ టాకింగ్ అనేది వెరీ వెరీ ఇంపార్టెంట్. టాకింగ్ అనేది వెరీ వెరీ ఇంపార్టెంట్.